Okay, so let's look at some problems from our review for our 4B test. The first question says, find the volume of the prism below. First thing you want to say is, what type of prism is that? It is a triangular prism. Now remember, prisms are different from pyramids because prisms have two bases. This one, the base, is a triangle. First thing we want to know, we're finding the volume. So we need to look up our volume formula, and volume equals area of the base times the height. So to find that capital B for this triangular prism, we have to do the little b, which is the base, times the height, divided by 2. Now remember, I told you to look for the base and the height, and they need to be perpendicular. So in this instance, the base is 12, the height is 3, and we're going to divide that by 2. So 12 times 3 is 36, and 36 divided by 2 is 18. So 18 is our capital B, the area of the base. So the area of the base is 18 times the height of the prism. Remember, the height of the figure connects the two bases. So 18 times 5.3. 18 times 5.3 is 95.4 centimeters cubed. Okay, let's look at the next question. Sandra is building a square sandbox with sides 9 feet long. She wants to put 1.15 feet of sand deep in the box. How much sand should Sandra order? Well, let's look at our formula. Volume is capital B times H. In this instance, we've got a sandbox that's 9 by 9, so the area of the base is 81. We want the sand to be 1.15 feet deep. Go ahead and multiply this out, and you end up with 93.15 feet cubed. So the answer here is A. Okay, let's go across the paper and look at question number 4. A cylindrical oil storage tank has a height of 18 meters and a diameter of 34 meters. If the tank is full, how many meters of oil to the nearest tenth does it contain? Well, I'm going to draw my tank so that I can see what I'm looking at. I have a diameter of 34. That means I have a radius of half of that, which is 17. And then I need to find out my volume. So I'm going to use my volume formula for a cylinder, which is volume equals area of the base times the height. Remember that area of the base for a cylinder is a circle, is pi r squared. So pi, I'm going to put down 3.14, the radius 17 squared, and I go ahead and find that answer out, and I get 9,746, and I need to multiply that by my height, which is 18, the height of the cylinder. So when I multiply that by 18, I end up with 16,334. So the answer here is D. Let's look at the next question. Question number 5. A box of Rice Krispies holds 240 cubic centimeters. So we're dealing with volume because cubic. The length of the box is 8 centimeters and the width is 3 centimeters. Find the height of the box. Well, we can use our volume formula for a prism. Volume equals area of the base times the height. I know the volume is 240. I know that the length of the box is 8 and the width of the box is 3. I'm trying to find the height, so I don't know. That's my unknown variable. So I'm going to go ahead and say 8 times 3 is 24. So 240 equals 24 times the height. Divide by 24 on one side. That gets me h by myself. Divide by 24 on the other side, and the height of the figure is 10. Okay, so let's move down the page and look at question number 3. Number 3 says, calculate the volume of the pyramid. Well, we need to go ahead and write down what is our volume formula for a pyramid. Volume for a pyramid is 1/3 of the area of the base times the height, because a pyramid is 1/3 of a cube. So we have to figure out what is the area of our base. Well, to find the area of the base of this rectangular or square pyramid, we can do side times side or base times height. So here we have 4 by 4, so 4 times 4 is 16. So that is our capital B. So 1/3 times our capital B, which is 16. The height of the pyramid is marked right there, 6. So we go ahead and we multiply. We get 1/3 times 96, and 1/3 of 96 is 32 feet cubed. So the answer here is B. Okay, let's go across the page and look at question number 6. The cone below started out as a cylinder with a corresponding base, area, and height. The cylinder's volume was 99 cubic feet. Then hungry beavers attacked the cylinder. What is the volume of the cone? Well, you can use your volume formula for a cone. Volume is 1/3 of the area of the base times the height. Well, if you remember correctly, when we discussed the cone and we did the rice experiment, a cone is 1/3 of the volume of a cylinder. So basically you could just say that 1/3 of the cylinder's volume that you just read about is 33. So this cone, when it was eaten by beavers, is now 33 feet cubed. Okay, so let's turn the page and look at question number 7. Farmer Ben fills the silo pictured below with the grain he harvests each season. This year he harvested 1,000 cubic feet of grain. Assuming all silos are the same size, what is the least amount of silos he will need to store all of his newly harvested grain? Well, the first thing we need to think about is, what is the area of this base? So we need to find this volume of the base, so we have to find the area of the base, pi r squared. Pi is 3.14. Radius squared is 3 because the diameter is 6, so the radius is 3 squared. Okay, so 3.14, 3 times 3 is 9, and when we multiply that out we get 28.3. Now remember, volume is the area of the base times the height. So we found the area of the base is 28.3, sorry. The height of the cylinder is 12. So we go ahead and multiply that out, and we find the volume of the cylinder is 339.6 feet cubed. Okay, so that is how much this silo will hold. But he harvested 1,000 cubic feet. So I need to take 1,000 and divide by 339. When I do that, I see that 339 does not go into 1, it doesn't go into 10, it doesn't go into 100, but it goes into 1,000 two times. And I can go ahead and put my decimal point there, and then I can go ahead and go below 339, and I can subtract, and I can continue on, and I find out that it's going to be 2.94. Well, I can't get 2.94 silos, so I need about 3 silos. So the answer is B. Let's go across the page and look at number 9. Reese bought a container of oatmeal as shown below. If 2/3 of the oatmeal has been eaten, how many cubic inches of oatmeal are left? That's the key word. So we're going to have to do a number of things to find this answer. The first thing we need to do is we need to remember what is our volume formula. Volume is area of the base times the height. I need to first of all find my pi r squared. In my cylinder, the diameter is 4, so the radius is 2. So I say 3.14 times the radius 2. 2 squared is 4. I go ahead and I multiply that out. I get 12.56. Okay, I'm going to multiply that by my height, which is 6, and I get 75.36 cubic inches of oatmeal that is in the container. Okay, she ate 2/3, so I have to multiply this by 2/3 because she ate 2/3. So she ate, when you multiply that out, 50.24. She ate that much oatmeal. Okay? Now I need to figure out how much is left. So I'm going to take my total here in my container, 75 minus 50, and I find out that I subtract, and I find out that there's about 25.12 inches cubed of oatmeal left in this container. Okay, so let's go down and look at question number 8. Mia has an exercise ball in the shape of the sphere shown below. She wants to increase the weight of the ball by filling it with water. Which is closest to the amount of water in cubic inches that Mia's exercise ball will hold if it is completely full? Now remember, the formula for a sphere is 4/3 times pi times the radius cubed. So I'm going to go ahead and do 4/3 times 3.14 times 6, because the diameter here is 12, so the radius is 6 cubed. Now remember, I'm going to go over here and I'm going to go 6 times 6 times 6 first, and then I'm going to multiply that by pi, and then I can multiply that by 4 and divide by 3. So when I do that, I get 904.32 inches cubed. So the answer is C. Let's go across the page and look at question number 10. Roger needs a bowl that will hold 2 gallons, 462 cubic inches of a punch recipe. He has a bowl that is in the shape of a half sphere with a diameter of 12 inches as shown below. So that's the bowl that he has. He needs a bowl, if you kind of draw it up above here, he needs a bowl that holds 2 gallons. That's what he needs, or 462 inches cubed. That is what he needs. Okay, this is what he has. So I'm going to go ahead and figure out 4/3. I'm going to use my formula for finding the volume of a sphere. 4/3 times 3.14 times, as you see here, the diameter is 12, so the radius is 6 cubed. So when you go ahead and multiply that out, you get 904.32 0.32 inches cubed. It's not a whole sphere, it's a half a sphere, so I have to divide by 2, and I get 452.16 inches cubed. Now, this is the question. Roger needs a bowl that holds 462 inches cubed. He has a bowl that holds 452 inches cubed. Is his bowl big enough? No, the bowl is too small. Okay, now let's switch over and let's look at some surface area problems to remember some things. Let's look at number 12 on the next page. The roof of the doghouse is a square pyramid that has a slant height of 4 feet. So remember, slant height is that funny looking L, and a base side of 5 feet for every dimension. So basically that's a square pyramid. If shingles cost $1.25 to cover 1 square foot, how much would it cost to put new shingles on the roof of the doghouse? The first thing I do is I draw my doghouse kind of with the roof. I know that the slant height is 4 feet and the base is 5 feet by 5 feet. Okay? So let's pull up our surface area formula for finding the surface area of a pyramid. Surface area of a pyramid is 1/2 capital P, perimeter of the base, times the slant height. So let's go ahead and look at that. So we have 1/2 times 5 plus 5 plus 5 plus 5. 5, 10, 15, 20. That's the perimeter of the base. The slant height is 4 feet, so we go ahead and plug in our formula. You can say 20 times 4 is 80, and half of 80 is 40. Or you can take half of 20, which is 10, and 10 times 4 is 40. So the doghouse is 40 feet squared. Now it cost $1.25 to put shingles on the doghouse. So $1.25 times 40 square foot, go ahead and multiply that out, and you find that it is going to cost you $50 to put shingles on that doghouse roof. Okay, let's look at question number 13. Gary wrapped a cube-shaped gift box with wrapping paper. The box was 8 inches long. What was the minimum amount of paper Gary could have used to cover the box? So I'm going to look up that it's a cube, so I could actually draw and see that he made a cube. My cubes are not perfect. 8 by 8 by 8. He needs to wrap this. So I look at my surface area formula. Surface area of a cube or a rectangular prism is the perimeter of the base times the height plus the two bases times capital B, the area of the base. So I'm going to go ahead and I'm going to plug in my perimeter of the base. Remember, bases of a cube have 4, so 8 times 4 are 8 plus 8 plus 8 plus 8. So the perimeter of my base is 32. The height of my figure is 8, plus I have two bases. So I'm going to say that my base is 8 times 8, which is 64. 64. And I'm going to go ahead and multiply 32 times 8. I get 256 plus 2 times 64, which is 128. When I add those together, I get 384 inches squared. So he needs about 384 inches squared of wrapping paper to cover his box. Okay, so let's jump to the back page and look at some cylinders and remind ourselves about finding surface area of cylinders. Now remember, lateral is basically the sides without the bases, and the total surface area of any figure is the sides and the bases. So here you're finding the lateral surface area and the total surface area. So if you go ahead and you write out your full formula, surface area equals 2 pi r h. Remember, that is that rectangular part in the center, plus 2 pi r squared. Remember, that's your two circles. Okay, so we're dealing with our radius. We have our diameter. Our diameter is 3.5, so I have to divide that in half. So our radius is 1.75. Okay, now you can come below here and you can plug in, as long as you realize that this part is the lateral, and when you put them all together, then you're going to get your total. So I'm going to go ahead and I'm going to plug in 2 times pi, 3.14, times the radius, 1.75, times the height, remember the height of the figure, 13. Okay, I can solve that, and I find out this part equals 142.87 centimeters squared. So my lateral is 142.87 centimeters squared. Okay, then I can come over here and I can add the next part of this formula. 2 times 3.14 times the radius squared, 1.75 squared. I want to do that part first, so when I square that I get 3.1. So if you go ahead and multiply 2 times 3.14 times 3.1, you get 19.5 centimeters squared. I need to add those two figures together, and you get 162.37 centimeters squared. So the total surface area of the cylinder is 162 centimeters squared. And then you can go ahead and find the next one using the same formula. Now remember, on your test you will have volume, surface area, and you need to know the difference between lateral and total, and then you're going to have proportional change of volume questions like we've done the past couple of days. So remember the formula for that change, the proportional change of volume. Proportional change of volume. Whoops, disappeared here. Okay, so our proportional change of volume formula is the old volume, or the original volume, times the scale factor cubed, and you get your new volume. Now remember, if you're trying to find area or surface area, then you would do old area or surface area times the scale factor squared equals the new area or surface area. So study hard and good luck.